This is part 12 of the Creed 7B Teleprinter restoration series. In this video I'm looking at reinstalling the solenoid, which is this. It's quite a bulky solenoid, but all it really does is provide a two-position state for the mark or space signals that come into the teleprinter. So this is the arm that connects to the receiver module that we've already looked at, and we'll look at a bit more in a few minutes when I install this into the machine. But just thought it might be interesting to have a quick look at this before I install it. It's quite a clever device, and what I've done so far is taken out the bearing blocks, cleaned the bearings out, re-greased them, and cleaned out the slots that the armature runs in. The main disadvantage with designs like this is that these very small slots fill up with dirt and debris, and then the armature can't move anymore and the machine stops working. So this is a two-position latching solenoid. Despite how I've described it in the previous videos as being energized or de-energized, that's not really how it works. There are two pole pieces, so one this side, one this side, and then joining those together there's two horseshoe magnets that run underneath the solenoid, and that means that what we have is two magnets, a north and a south pole, and because we have an iron armature core, then what happens is if you put the armature in one position, because we have a north and a south pole, then the armature will stay in that position. If you push it across the other way, then it will stay in that position until it's moved back again. The way it's normally moved is using the two coils in the center. I'll just quickly demonstrate it. I've got it hooked up to a power supply. If I turn the power supply on, you can see it changes state. I'll turn the power supply off. You see nothing happens. If I manually move it back and do this again, you can see it changes state. If I leave the supply on but swap the polarity of the current, you'll see that it goes back the other way. And if I swap it again, you see it goes back the other way. So in other words, we're actively driving it in both directions, and that enables the solenoid to switch much more quickly. It also means that while we can switch it very rapidly, we don't need very high currents to do that, because we're not overcoming a very strong spring, and we'd need a strong spring to have it operate rapidly if it acted as a standard simple solenoid. So in other words, what we have here is just a two-position latching solenoid. There are two coils, but essentially they're used together just to give us higher performance and faster switching. But that's all this does. It takes the serial data coming from the sending machine and it just interprets that as a mark or a space by moving the armature one way or the other. Okay, it's a very simple device. What I'll do now is get it installed into the printer, and then we can see how it connects and how it operates the receiver mechanism. Okay, so the solenoid fits in this position and it attaches to the receive module through this link. It just sits on top of the machine and it has sprung contacts which make electrical contact with these four pins. This is fixed and this just sits on top. Makes it very easy to fit, very easy to exchange if there's an issue with it. It is adjustable, so we'll look at adjusting it later if we need to, and that's just to make sure that this push rod is in the correct position depending on what state the solenoid is in. So the only difficulty in fitting this is that we need to attach the arm to the solenoid, and we can't really do that after the solenoid's in place. We need to slot it through here first, drop the solenoid onto its locating pins. There's a pin at the front, a pin at the back. The pins don't go into round holes, so we can move the solenoid back and forth, but it does locate it from left to right, which means that the adjustment for the position of the push rod should be pretty much correct. So we'll put the bolts in, one at the front, one at the back. I'll lightly screw it down. Of course it's sprung up because we're on the contacts at the back. and as we tighten the screw it will push it down onto the contacts, and I'll check later on that they're making good electrical contact. So once we have that done, then the next step is to clip the arm into place. So there's kind of a little spring clip here, and all we do is we lift the top part of the spring clip, engage this on its little locating peg, drop the spring clip, and then that is now installed. And although you can't see it, what it can do now is raise and lower the position of the little selector arm that we looked at previously. So if I push this across, then the adjustment we need to look at is that the little selector blade here is in line with this pin. So I'll move the camera across slightly and zoom in so we can see the correct location and see if it needs adjusting. Okay, so hopefully you can see this now. This is the blade that we're talking about, and this is the part of the receiver mechanism that the solenoid controls. It's swung in and out by the cam on the receiver module, but the actual position in terms of height and its alignment with this pin is determined by the solenoid position. So currently it's in the mark position. If I change it to the space position, you'll see this move down. So I'll pull the solenoid back to its space position, and you can see now that this is now way underneath this pin. If I move it back the other way, you can see it moves back up and it's back in line with this pin. If I rotate the receiver mechanism, you'll see that this allows us to control the setting of these fingers. So I'll start to rotate the receiver. You'll see that this pin has been pushed across into the mark position. That pin has been pushed across into the mark position. That's the end of the cycle, so it will move back and reset itself now. But what's happening now, it's gone into the idle mode because it's at the end of the character. So I'll trigger the solenoid manually to put it into the position for the start bit. So we've now got the start bit. That's caused the mechanism to start. And if the first bit was going to be a 1, then the solenoid would receive a 1 from the sending machine, and it would cause the arm to come up. That would set the first of the fingers. If the second bit from the receiving end is a 0, then it will cause the solenoid to be forced the other way, and then the next bit will be left. So the finger is left because this is now below the pin and the pin isn't pushed across. If the next bit was to be a 1, then we would receive a 1 electrical signal from the sending machine, which will cause the arm to raise, push that pin across. If the next one's a 0, etc. So it just continues like this until it reaches the end of the bite, and then the solenoid moves to its home position to give it the required stop bits. And now we're once again back into its rest position. If further stop bits were required, then the solenoid would create those and allow the machine to drive back. The number of start and stop bits depends on the physical characteristics and layout of the machine, but this is what they're for. They're there to start and stop this mechanism depending on what data has been received. Now, the reason that this solenoid is a two-way acting solenoid, as I said, is for speed, but it's also the reason that the signals are differential signals. It's the reason that they are plus minus signals being fed to the solenoid, not just a 0 or a positive voltage. So to move from mark in the up position, then the solenoid is pulsed with a positive voltage. To go back to the 0 position, it's pulsed with a negative voltage. So if it's pulsed with positive voltage, it goes that way. If it's pulsed with a negative voltage, it goes that way. And that's all that the sending system does. It just toggles this between the two states depending on whether it's sending a 1 or a 0, and it's then up to this entire mechanism to turn that into an actual selected character and then to print that character. But that's all really it does. The rest of the machine is just there to provide the functionality to handle the incoming data. Okay, so that's the solenoid fitted. I will test it off camera to make sure it's electrically connected and that it works through the signal control cable, and then in the next video we can look at fitting the start-stop motor switch, and again that's controlled through the incoming data stream and through a timer.